Hi. Exam. It's exam 1 review and no one is happy. Right? You guys have to do it and I have to grade it. So it's... there are no winners here.
You want me to grade it? I'll grade it.
So, now we're talking. So, exam 1 is on chapters 1 and 2. That's 1 and 2, not 1 plus 2 is 3. So chapters 1 and 2, sections 1.1 through 1.4, which is review of pre-calc, and 2.2 through 2.7, which is limits plus continuity. So that's the material. We covered everything in class and some extra as well. So few pointers. Let's go. There are going to be 10 problems. And then it's 100 points. So the grade on the exam will be out of 100. So the types of questions, there on my exams, there's always, one question or maybe 2 questions to state the definition or the formula or something. So I did tell you, I'll write it in blood now, definition of the function is 100% there, right? Function is a rule which assigns to each x in the denominator a unique y in the range. So that definition is 100% there. Now, other things you are looking at regarding pre-calculus is computing function values, which is, figure out f of 3 and stuff like that. Number 3, graph basic functions. Plus shifts, plus reflections. So that's 1.6, I believe, in your pre-calculus book. Number 4, this one also should be in blood because it's 100% there. Function composition. This means I give you 2 functions, you plug one into another or the other way around. And then number 5, inverse function. So this covers your pre-calculus component. Now you're looking at 5 bullet points and you go 5 problems. No. 3 problems, maybe 4 problems. See, definition of a function is 4-point question, right? So if I'm going to keep about 30-40% of the grade in pre-calc 1, which sets the stage for calculus 1, then you can expect maybe 4 problems, I would say, but not each one is 10. So maybe you are going to end up having 11 problems on the exam because definition of a function is going to take, let's say, 4 points, and then compute something for 2 points and compute something else for 2 points, whatever. So it's easy to come up with these kind of things. It's good to know, obviously, domain and range and all of these x, y intercept and all that kind of stuff. But we're going to come back to that in our course, so we'll use it eventually. And so that's pretty much everything for chapter 1. For chapter 2, I'm going to leave some space in between. So for chapter 2, we are focusing on limits. And the limits can be computed as plug-in. They can be computed as, now let's not start with plug-in. Let's start with the graph and the chart, because both of those are in 2.2. Then we can do plug-in if the denominator is not 0, and algebra if the denominator is 0, and those would be 2.3. Then we have the squeeze theorem, also 2.3. And for limits, well, I think that's it. We have limits at infinity. No, sorry, first goes infinite limits. And then limits at infinity. No coughing. 2.5 and 2.4 over here. Now, infinite limits give us what? One in particular. Vertical asymptote. So infinite limits give rise to vertical asymptote. And the question might be, state the formula for vertical asymptote. Well, it's just going to be the limit, right? Limit x goes to a of f of x is equal to positive negative infinity, vertical asymptote at x equals a. Because your vertical asymptote is always the same value where this one goes, where x goes to in the limit, if you get infinity. Now you can do the one-sided limits, obviously. And on the other end over here, what's happening with limits at infinity? That gives us, very good, horizontal asymptote. And this is limit goes, x goes to positive or negative infinity of f of x to be finite number L, and then we say ha at y equals L. Horizontal asymptote. Number 7, continuity. Which goes into continuity at a point. That's the 3 rules you have to memorize. Global continuity, that's those 2 theorems. And finally, discontinuity. There is a piecewise continuity. Those 3 graphs we had where, one thing fails and you figure out which one it is. So that's the continuity part. We are not going to have the intermediate value theorem on the test even. It's on the lab. I need to talk about it, but it's not on the exam. And number 8, we have the definition of the limit. That's in 2.7. And you are responsible for the statement and those 2 pictures that are associated with it. So this is the entire exam. Obviously, when I said limits, that covers 4 sections, and the 4 sections in there would be can generate a number of problems. Every other page on the exam is going to be blank. I am going to kill the maximum amount. Well, it's not a killing maximum amount of trees. I can insert 4 blank pages in between each printed page, and then you can kill more trees with this. But the exam will be printed one-sided, which means that the other side that's blank you use as a scrap paper. At the back of the exam, right when you turn the exam over, the whole page is blank. That's reserved for art. Draw something nice if you finish early. You can also write a poem, short story. I had students put in computer code, which then I have to edit, so please don't. Because it's like, yeah, I know Java. I said, you missed so many of these. There's a lot of things I have to fix here. So, so that's the last page is reserved for creativity, something that's going to hopefully make me laugh and lessen my misery looking at these things for 5 hours, all right? The funnier it is, the better mood I'm in.
More points we get? Pretty much how it works.
Well, the points do not, these are, but. Yes.
Should that be on the front page? Because if it's on the back page, you're just going to be in a better mood for the next.
No, because
front and back, right?
Because
Yeah.
no.
With the whole test then.
I appreciate your concerns, but no. Now let me say why. When I collect exams, I put them face down, and I look at the last page first, because when exam is, depends on the spice level, you might have an extra question in the end, which you can use to replace any other problem on a test. So, let's say there is an extra page, and the problem on that page is not numbered, and there is the text on top that says this problem can be used to replace any problem on the test. The other problem would not be considered for grading at all if you replace it with this. And then there is like a contract line which says, please replace problem number and a blank, so you put, 7 or 3 or whatever, with this problem and a place for you to sign and date, which means that's the contract. And if that is present on a test, that's why the exams are upside down. I first open and see if you are replacing any of the questions. So if you replace number 3, then I flip to number 3 and I cross it out whether it's right or wrong, because it's not considered for grading at all. If it's blank, it gets crossed out. If it's written something crossed out, and the last problem is graded instead of that problem that you decided to replace. So that's why all of the art and everything goes in the back, because that's the first thing I see. Then I take a look if you decided to replace any problem. Then I go into the exam. All right? That's the way it goes. So the last page is there. People draw comics, and I'd rather be sailing. It's a little scenery over there. It's sail. Sail 30%. I'd rather be sailing. All right, let's go. What else? Any other questions? So I gave you the list of topics. I did tell you that you might have to state the definition of the limit definition, 3 rules of continuity, any of the blue theorems of the continuity, the left and right theorem, right, for the limits, which is if the left and right limits meet at the same value, the overall limit is that value. So you can have any of these as a problem to state for points, and definitely the definition of a function, which is definitely there. The exam is meant to be solved in 1 hour and 20, which is the time limit. Then there is a break, 5 minutes. If you really have to work extra 5 minutes, okay. I won't wrestle you. If you are done early, you can work on your art, right? There are a lot of things that you can calculate in addition to what's there. Number of cinder blocks in the wall, the area of the floor and ceiling and all this kind of stuff. It's just a lot of things that you can come up with to kill your time. If you hand it in early, I need you to be stealth like a ninja. That means I don't want to hear zipper of the bag and keys like this for 20 minutes while the rest of the people are trying to do the exam, because you're so self-centered and I'm the only one on this planet, and the rest of you keep doing your exam, right? So put your keys and close the zippers and everything on it if you, right? Since it's a Thursday class, it's a 3-hour class, we are going to have lecture after the test. This course ends in December. It doesn't end after exam 1. Because what happens is people just, hand in exam 15 minutes early. We don't have to check because whatever. To get home 15 minutes early, but then there's another hour and a half, and I'm going to teach 3.4, which is product rule and quotient rule. That's, I think, 3.4, product rule and quotient rule, and that stuff is going to stick with you. Calc 1, Calc 2, Calc 3, and differential equations. You're going to have something called exact equations in differential equations, which is going to be the product rule, some manipulation of the product rule. In Calculus 2, you're going to learn integration by parts. That's going to be backwards product rule, right? So, if you bolt out of the exam, well, obviously there's going to be a stream and stuff like that, but it's not the same, I'm here live, you can see the show. It's not the same, like, you're in a basement looking at it. Looking at a little YouTube video. So that's that. We'll start the class obviously on Thursday with the exam, and then we'll have the lecture afterwards. The lecture is not long, so we might finish a little bit early, and that's it. Any questions, concerns regarding this before we hit the second part, which is where you ask questions, math questions? Yes.
Can I ask one question?
Sure. Any housekeeping questions? Bathroom before, not during the exam. No graphing calculators. Yes.
Have you ever made your own mayonnaise?
No. There is so much of it if you go to the store. I don't know if you've ever been. There's a whole aisle. I mean, not in the aisle. There's like section.
You could have made it like 10 times better if you just made it yourself.
No, he's got a point, Professor.
You need to buy chicken.
That's how it works.
To get eggs and then make mayonnaise using.
You can customize it.
But if you make love,
Customizable mayonnaise.
You're a genius. Dude, we should go.
Apparently, part 2 of this review would be cooking show. So we're going to take a look at the recipe for mayo. We need oil, we need eggs, salt.
A little bit of love, passion, care.
Love and passion of a Slav, yes. Which means that a whole bunch of you noobs are disqualified. I know, you gotta be born pure. What can I say? All right, let's go do some math questions.
I just wanted to review the Squeeze Theorem a little bit.
Okay. So there are very few problems given along the way because it's very specific. We generally use it to deal with the situation when you have oscillation. And the problem we discussed in class was the limit of x squared sine 1 over x. You can have cosine as well. It doesn't really matter, right? Cosine 1 over x. And we send x equal to 0. Now, in this situation, if you send x to 0, you get a cosine of 1 over x to be cosine of 1 over 0. And 1 over 0 goes to infinity. So when it goes to infinity, it oscillates very fast. And we cannot really judge whether the limit is finite or not finite. So we try to use the squeeze theorem to literally squeeze this function between two other functions that we can compute limits of. And because it's squeezed in between, if the other two limits fall in the same place, where this one that is squeezed in between has to fall in the same space. So we start the problem by remembering that the cosine of x is bounded by 1, which means that the range of cosine function is from -1 to 1, and from there we can write that -1 is less equal than cosine of 1 over x is less equal than 1. Now we're going to obviously plug here 1 over x, and then we're going to go from that place there. So now when I have this, I compare the middle with the problem over here, and I notice that x squared is missing, which is now where I take the x squared, right, and plug x squared to every one of these. So this is a three-sided inequality, and we get negative x squared less equal than x squared cosine 1 over x less equal than x squared. And now you see that the function that we are examining in the limit is squeezed in between two functions that are easy to deal with. So we constructed these. We don't guess them, we construct them from what we have to start. And now when I take the limits of all three of these, I have limit of negative x squared as x goes to 0, and that limit is 0. And over here I have the limit of x squared as x goes to 0, and that limit is also 0. And now this one is stuck in between the limit x squared, and that's the one I don't know, right? I don't know what is happening for this one. But if you consider that this one is 0 from this side and this one is 0 from this side, what can you fit in between two zeros? Well, the only thing you can fit is another 0, so this one has to equal to 0. Does it make sense?
Yeah.
So now you can have different functions. You can have ln, you can have, it doesn't matter what you have, you are building it out. And when you build it out, you just try to find one function below, one function above. But it's always this kind of procedure where you multiply. And now I noticed that a whole bunch of problems in the book, they actually give you this. You don't actually have to even create it. You just need to take three limits and say that the one is stuck, right? Because the middle one you can never solve, right? That's why we have the theorem. So in the book, in general, they give you this one right off the bat, and you just take the limit here and take the limit at the end, and then if those end up being the same number, well, the thing in between falls in the same number, because the only thing you can squeeze between 2 and 2 is 2 itself, right? So it's across the board. So that will be the squeeze theorem that was mentioned in there. Anything else? A problem of some kind, the limit of some kind? Yes?
What are the two pictures that have to do with it?
They are in the lecture, so here. Picture number 1, and then picture number 2. So those are the two. One shows when you squeeze here, it squeezes there, so the A will fall into L, creating the limit. So the first picture is the limit as x goes to A of f of x gives you L. So as you squeeze, it will squeeze, and it will squeeze at the same time. The one on the bottom, we said limit does not exist, because as you squeeze these deltas here, the y values go apart. So that's when the limit does not exist. Cool. Anything else?
Can you do one more example of limits at infinity?
Limits at infinity? Yes, which one?
Can you do one more, like?
Sure, I can do 15, I just need them. I just need a problem. So limits at infinity is when you send x to positive or negative infinity. So we'll just wait for the problem. That's what I said, that right as you are coming here for the review, you just have the problems ready, and I will be solving as many problems as you have. If it's a 2-hour review session, it's a 2-hour review session. It's okay. Right now you provide questions, I provide answers. On Thursday, I provide questions, you provide answers. We swap, right? We said no lab.
Oh, no lab questions?
No lab questions. That's graded material. Huh.
Okay. So then...
So he's going to change 2 into 3 now. He says not a lab question.
Oh,
it's called a loophole.
That's smart. That's smart.
I was born that way.
So does that still count? Can I still...
Oh, no. Currently I'm just bored. Someone, please, help me out. Oh, you have a question. I can do 15 of them, just get them. Limit x goes to -1 of 2x minus 1 squared minus 9 divided by x plus 1. Awesome. Thank you. Holy nightmare. We can't plug in over here. Can't plug in because when you plug in -1, we have 0 in denominator. So plug in method. No. Can't plug in. So what are my options? Well, I don't have many. It's polynomials, right? So maybe I get lucky if I FOIL this, and then if I square it and then subtract 9, maybe we would be able to factor it differently, right, than what it's factored as right now. Like, that's the only thing I can think of, and if that fails, we can always use the chart of values, right? Because you can rise from the left to -1, you can fall from the right into -1, and then see what the left and right limits are going to, and if they go to same value, we're done. But let's try and work out some of the algebra magic first. So x goes to -1, and now I need to square this. So I have 4x squared minus 4x minus 8 divided by x plus 1. So, yeah, okay, that's when we FOIL. Now you can see that you can kick out 4. So limit x goes to -1. You can kick out and have x squared minus x minus 2 divided by x plus 1. Now this 4 can be kicked out in front of the limit. We learned that as a property. So you can kick it out all the way in front. And now we can factor out this one into x minus 2, x plus 1. That's the boss move right there, see? So x plus 1, and now these two annihilate each other. Great. We have 4 times -1 minus 2 for a total of -12. Now, let's say you care and you want to check this, hypothetically, right? Speaking. What do? Well, what you is you go to your favorite software, whether it's Mathematica, Wolfram, or Symbolab. You punch this question in and you hope it gives you negative 12. Because you can do that, right? So, just to kind of verify that this is all good, I'm going to open up new window, go Wolfram Alpha, and say limit of double open parenthesis. We have, what was that, 2x minus 1? And then that was squared. And then now we have minus 9. And we're going to close parenthesis. And we're going to divide that with the open parenthesis of x plus 1, close parenthesis, as x goes to negative 1. So you just talk to it. All right? Talk to it. Push enter. And now wait for negative 12 to show up. And there's negative 12. So we're good to go. So you can check your problems if you care. And it will tell you. Now, if this was, let's say, a lab question, I print this page. That's one of the 5 that gets stapled in the back. Right? That's it. That's one of the 5. Good. So that's that part. Any other questions?
Like that one, on the homework, x to the 6 minus 2x to the z over x to the z.
Yeah, I'm going to walk all the way there. X goes to, so limit x goes to 0 of x to the 6 minus 2x to the 5 divided by x to the 5. We cannot plug 0 because it creates 0 in denominator. So what I'm going to do is factor. Now we can factor out x to the 5 in the numerator. So that's going to go out. And we are left with x minus 2 divided by x to the 5. These guys cancel. And now when I plug in 0, it becomes negative 2. And that should be good to go. Now, if my MATLAB says that's wrong, well, sometimes the programming is off.
Oh, it's at x minus 2. They're looking for the equation, that's why.
Oh, they're looking for the equation. So you did the problem correctly.
I
You
did.
just
I just entered in the wrong one. I've done
Okay.
that a couple times.
well, that's the issue with reading.
Yeah.
I can't help. I'm not authorized. Yes.
Divide the numerator and denominator by the highest power of x in the denominator to find the limit. Limit x goes to infinity. Root 64x squared minus 512.
512.
Yes. Over x minus 8.
X minus 8.
Yes.
Good. And I'm supposed to solve. We're supposed to find the limit here.
Yes.
What is? It's 8. It's obvious.
That's it.
Yeah.
Oh yeah, I totally need that. Yeah.
Yeah. All right. That's okay. So To solve these problems, when you have x goes to infinity, you are supposed to find the highest exponent in the problem and divide every term by that exponent. Now, what are the exponents we have? Well, over here, we have square root of x squared. Square root of x squared is actually x. This one has exponent of 0, so we don't care. And then this is also exponent of 1, and this also has exponent of 0. So I have the highest exponent to be exponent x to the first power. Since x to the first power is the biggest exponent, I'm going to divide each one of these by x, and the whole square root gets divided by x. So now, you hit the limit. You don't hit the limit, you rewrite the limit. You rewrite the limit as x goes to infinity, and then x divided by x is 1 minus 8 over x. So this is denominator. That was cheap and easy and fast. Now in the numerator, x is going to go under the square root, and it's going to pick up a power of 2 because it goes under the square root. So now the square root is going to become tall because we're going to have 64x squared divided by x squared minus 512 divided by x squared. So when that x jumped into the root, it picks up the power of 2. Now you can see that you can, right, this is a common denominator, you can factor 1 over x squared, and then when it jumps out, it will come 1 over x. So now at this time, every one of these becomes 0 because you are dividing, let me write it in blood, dividing finite number by infinity. Technically, you are chopping it into oblivion, right? There's nothing left because the more, where are my mayo experts over here? The more you chop the onion, right? The finer it gets. All right, good. So now, what is left? Well, now limit is used up, right, to send these to infinity. You have these x's over here cancel, and the whole thing that is left is the square root of 64 divided by 1, which is 8. There should be one of these bad boys on the test. They're so nice. And this method, right, knowing this procedure to divide by the highest exponent, I believe in class we had either dividing by x squared or x cubed, the example I did in class. So as you're dividing by these values, you are looking for the highest exponent and divide every term by that exponent. And if you have to, go into the square root, you pick up a square. If you go into the cube root, you pick up a cube, and so on. So if you're dividing by x squared and you go into the cube root, then it's x to the 6th, right? Because it picks up 3 times, and you already have a square, so it becomes a 6. Cool. Anything else? Yes.
Find the horizontal asymptote of 3x squared plus 1 over x squared minus x plus 2.
So that's the same problem. Okay, good. So find ha for f of x is equal to, what's in the numerator?
Numerator 3x squared plus 1.
And denominator?
X squared minus x plus 2.
Plus 2. Okay, great. So those of you who memorized the rules from pre-calculus, you know that since the exponents are the same, x squared and x squared, the horizontal asymptote is at the ratio of the front coefficients, which is 3 divided by 1. So y equals 3. Answer is y equals 3 because you know pre-calc. But how do we do this using calculus definition for the horizontal asymptote? Because on the test it will say, same question on the test, and it says, prove that the horizontal asymptote is at 3. So you are given the function, and you're also given the answer, right? Prove that the horizontal asymptote is at y equals 3. Well, if that's given to you, right, do you know that you have to run the limit x goes to infinity of 3x squared plus 1 divided by x squared minus x plus 2, no coughing. So now this is going to be the same calculation as last time, where we divide by the highest exponent. The highest exponent is x squared. So we divide everywhere by x squared. We have 5 terms. And when we cancel, limit x goes to infinity, we get 3 plus 1 over x squared divided by 1 minus 1 over x plus 2 over x squared. And again, we have the same situation. Each of these x's goes to infinity. Therefore, each one of them becomes a 0 because you are dividing, right, 1 or 2 units of something infinitely. So the answers are all infinitely small, which means 0. And you are left with 3 over 1, which is 3. So we say horizontal asymptote at y equals 3. So guys, this is full credit the way it's written here. Let me show you the way to lose 2 points. You write this nonsense. Ooh, I'm allergic to this. You have no idea how allergic I am to this over here. Y equals 3 has nothing to do with mathematics. Your horizontal lines are y equals a number. Your vertical lines are x equals a number. So please spare me the inner pain and depression and just write x equals a number, y equals a number for your vertical and horizontal asymptotes, and we'll be the best friends forever.
So if we want before that, the horizontal asymptote would be at 8.
Yes, it's the same type of a question. They asked just to find the limit, so sure, we just found the limit. But we could also ask, what is the horizontal asymptote for that problem? And the answer would be y equals 8, yes. Because anytime you are running the limit going to infinity, you are looking for horizontal asymptotes. When you are running the limit that goes to a finite number, x goes to 0 or something, if you end up with infinities, you are looking for vertical asymptotes.
Would the answer be different if it was negative infinity? Limit x goes to
It would not be different, right? Because it would just change the signs of the terms that die in calculation anyway, right?
Because here, like in this question, it's the same thing. But for x goes to infinity, it's always 1 over 3. And for x goes to negative infinity, it was...
That's because of the end behavior, yes. So you have those situations. In most cases, they both go. But e to the x is one of the examples where... And then that question there. So if you take a look at e to the x, the limit x goes to negative infinity for e to the x gives you 0. And the limit x goes to positive infinity of e to the x gives you positive infinity. So on one end you have the end behavior, which is going up, and to the right, on the other end, it goes to 0. So it's possible.
So how do I get negative infinity?
Well, you will actually use negative infinity in the calculation. But it will you see over here would be a negative number, and it would be because it's cubed, and that one would be a so for cubed or any odd exponent, the sign survives. So minus is minus, plus is plus. If you have even exponents 2, 4, 6, 8, then no matter which sign you start with, it's always positive, right? Because -1 squared is +1 and right, all of that stuff. So that's where the difference would be within that one term that has the cube in it. Anything else? Yes.
So when you find the vertical asymptote and the horizontal asymptote, it's just basically asking for the limit for the...
Yes,
Okay.
the two definitions. I believe I listed those at the front. Yes, I have. So this is your, right, these two. Those are the definitions for vertical and horizontal asymptote. If I say state the definition for the vertical and horizontal asymptotes, I'm looking for these formulas, right? Not the paragraph of which exponent is bigger or denominator is 0. None of that stuff. We in calculus, we only care about definitions and theorems, and these are the two definitions. Here's the vertical asymptote definition. You are going to a finite number, it spits out infinity. Here's the horizontal one, goes to any of the infinities, gives you the number, right, which is the horizontal line, and that's it.
Can we go through proving something's continuous, like an equation or something?
Sure. Do you have a problem?
I don't have a problem. I just wanted to know, like,
I'll find
the
it.
steps. Okay.
You can find it.
What
Because the
chapter is
steps
that?
are, if you are proving continuity at the point, you have to use those 3 rules. And if you're using global continuity, you have to call on those 2 blue theorems, right? So it's one or the other in terms of continuity, right? You are proving at the point or global. And in either case, you have to call the appropriate theorem.
Homeworks.
Beautiful. H of x is absolute 8 over square root of x minus 2. Use the continuity of the absolute value function, continuous, to determine the following function is continuous. Select the correct choice below and no, okay.
Yeah, I just want to go through the steps. Okay.
All right. So now, what do we do with this? Right? Is this continuous? Well, the first order of business is to deal with the absolute value. I'm going to write the absolute value definition on the side, and then we have to apply that absolute value definition to this problem. So absolute value of x is defined as positive x for all x's larger than 0, and defined as negative x for all x's less than 0. So when you consider this, if you pick, let's say, value 3, well, absolute value of 3 is 3. But if you pick a negative value, let's say negative 3, then it gets plugged in here, and then you have another negative in front, which creates a positive 3. So that's our hack way, right, to make all of the values always positive. So now, when I take a look at this h of x, right, h of x is going to have 2 parts, and now I need to know what these parts are. So how would we do that? Well, I need everything. I need to know for which values everything inside the absolute value is positive, and for which values everything inside is negative. So you have to solve 2 inequalities in order to come up with what goes here and what goes there, right? So what I'm going to do is I'm going to first work out 8 over square root of x minus 2 to be larger or equal than 0. So when I solve this inequality, I will have the values for which the function is above 0. So this becomes What? Actually, you know what? This is an easy problem. So let's not worry about that. Which value over here would make a problem?
1, 2, 4, 4.
4. Let's write it this way. Problem at x equals 4. Problem. That sounds like a math problem. So let's change that. How about the word issue? Issue. There we go. Issue at x equals to 4. Sounds good? So when x is equal to 4, this problem might not be continuous. We don't know, we have to check. But it might not be continuous. So what I'm going to do now is I'm going to run the 3 rules because I'm looking for continuity at the point. Because that's the only value that can make this problem infinite. You cannot come up with another value that would do that, right?
Do what x equals 4 does?
Yeah.
What about negative 4?
Square root of negative 4 is not real.
So wouldn't that create an asymptote?
Negative numbers are not in the domain because of the square root. We only worry about values that are in domain. So the domain of this function is actually only positive x's, right? That's the only, you start, okay, so issue at x equal to 4, and domain is, since we are not allowed, so domain is,
Start at 0.
we can start at 0 and go to infinity, right? Make sure you put the parenthesis on the infinity because you can't include infinity. Who's the only one who can count to infinity?
John.
I heard it. Who's the only one who can count to infinity? Chuck Norris. Twice. In 5 minutes. All right. So now we have the domain, and our function is clearly broken into 2 pieces. One is going to be 0 to 4, and the other piece is going to be 4 to infinity. So issue at x equals 4, we are testing point continuity at x equals 4. The rest we don't care. So what do I have for this one? Well, at x equals to 4, we have rule number 1, and rule number 1 says what? F of 4 exists. Rule number 2 says limit of f of x as x goes to 4 exists. And rule number 3, they have to equal each other. So whatever number you get in the first has to equal to the other one. Great, so let's check these. What's f of 4? Failed. Right? Not continuous at 4, therefore not continuous as a function. So it's not continuous.
So if there was that absolute value, we wouldn't have to do the part 1 and part 2 up there. We would just do one
Yeah,
part.
exactly. It will be just 1. But as you can see, we could even skip through the whole problem and just get immediately to the point where there is a discontinuity at 4. 4 is in the domain 0 to infinity, and we have 0 in denominator when that happens. So that's where the problem explodes. Done deal. Any other questions, concerns? Yes? Oh. No, I'm going to eat after this. I'll use more calories up. You know. This is my exercise for the week. Back and forth. It's cute. You have to factor this x minus b to the 30th power, which kicks out x minus b, and that x minus b would cancel. So that's way too complicated for the exam. We can talk about after that in class. It's a very interesting problem.
On the exam?
That one, no, because it will make pretty much everyone spontaneously combust. But you're giving me some really cool ideas. Any other questions, concerns? Oh, we have to be quiet. What's your question?
So is different quotient in chapter 3, or is that chapter 1?
So difference quotient calculation, guys, is a 2.3 limit question. So yes, it gives us the derivative, but the calculation is 2.3, so it's definitely fair game for your exam 1. Now, instead of me saying find the derivative using limit, I just say find the limit. I don't mention the word derivative. I just scratch it off, right? And if I want to put the same problem on exam 2 for chapter 3, I say find the derivative using limit, right? So difference quotient is a fair game for exam 1 because we did examples of difference quotient limit in 2.3, which I should be able to find when I go here. There it is. There is the difference quotient question done here. I'll label it as Dairy Queen. I mean difference quotient. So this is a difference quotient question where you have this is a difference quotient question for f of x equals 1 over x. You can always read what your function is in this location because it's f of x plus h minus f of x. So you know what the original problem is for because it's listed right there. So this is a difference quotient question for 1 over x. Now, did we do for something else, or did I had only one example? There was another one right up there. But I was talking mainly about difference quotient, and I gave you the formula for the difference quotient, and then I worked it out for the square. Now, if you had a limit in addition to this stuff, right, there would be a limit over here, then this age would go to 0, and the answer would be 2x plus 2. So the limit only kills that last age at the end. If you have a function in mind, we can do difference quotient problem. If you are okay with what you have seen in 2.3, then move on, right? With a smile. It's calculus, meant to make people happy, right?
Good question. When I have these functions, if I don't have a graphing utility, I wouldn't know, like if it's negative.
Yeah, that's too spicy for graphing. We are going to cover graphing of those particular functions in 4.4.
Okay.
So 4.4 will teach you how to graph these. Right now, you need to know 1 over x shifted left, right, up, down, reflected. You know, maybe so 1 over x squared. Of course, because you don't know yet how to deal with those. Past 4.4, you should be able to deal with them. You good? Any other questions? Confidence. Well, good. Going once. Going twice.
So.
Bye.